You'll notice your assignment today is on Alex. As it says AWS, that means it's an Alex assignment. We are going to have Alex assignments and pencil and paper assignments for this unit. I believe our test is all on Alex. I'll double check that and let you know next day or two. Okay, so we're going to get started. So I said we're going to work with right triangles. We're going to work with the Pythagorean theorem and its converse. You can kind of think about using the Pythagorean theorem two different ways, right? Using it and then using its converse. So the Pythagorean theorem says that in a right triangle, the sum of the squares of the legs, and that will be the length of the legs, equals the square of the length of the hypotenuse. Here's the question. Can you remember what the legs and the hypotenuse are? Can anybody remember? What do you think? Jamari, can you remember? Okay, so the sides of the triangle are going to be from A to C, so the length would be B, A, and C. Anybody remember? Pam, do you remember? Which side of the legs and which side of the hypotenuse? The hypotenuse is C. Exactly right. Well, the hypotenuse in a right triangle is always across from the right angle, right? So the right angle, remember, is indicated by this box. So C represents the length of the hypotenuse when we're using the Pythagorean theorem formula. So that's going to make A and B our legs. And it doesn't really matter which one we call A, which one we call B. The legs are the sides of the triangle that make the right angle, right? So A and B. So these are legs. So the length of segment AC is B, right? The length of segment CB is A, and the length of segment AB is C. When we talk about it, we're talking about the length of the sides of the triangle. So far, so good? Okay, does anybody remember what the formula for the Pythagorean theorem is? What do we use? We know it's got an A, a B, and a C. Anybody? What's that again? Remember, Kendall? Got a guess? Lennon?
A squared plus B squared equals C squared.
Right. A squared. So we just said that A and B are the legs, right? And the word that they're saying, the sum of the squares of the legs. So that's going to be A squared plus B squared. Sum means to add, right? Square in the A, square in the B, and that's going to equal the hypotenuse squared. Okay? Hopefully it's sparking a little memory, but if not, it's okay. It's not very complicated. We're about to do a couple of examples that should explain it. So what we're saying is, if the triangle is a right triangle, when we square the length of this leg and add it to the square of the length of this leg, it will equal the hypotenuse squared. If it does not, if we plug everything in and it's not equal, then it can't be a right triangle. Make sense? But if they tell us it's a right triangle, it will work. All right, so we've got two examples. We're going to use the Pythagorean theorem here to find the length of one of the sides that we don't know. So looking at example 1, the variable length of the side there is x. So is x, is it a leg or is it a hypotenuse? How do you know? Very good. It's across the right angle. While we're thinking about it, let's always remember too that hypotenuse is always the longest side in a right triangle. The hypotenuse is always the longest side in a right triangle. Don't really need that right now, but we will later. All right, so we're going to plug in to this formula here. You have it on your paper where you can see it, but I want you to be able to see it. So the legs, this side and this side, form the right angle, so that makes the side that is 9 units long and the side that is 12 units long, the A and the B. Remember, I could put B and A, that part doesn't matter. So we're plugging that in to the Pythagorean theorem. A squared, 9 squared, plus B squared, which would be 12 squared, equals our unknown length squared, our hypotenuse squared. So if the variable is the hypotenuse, we have to replace this C with that. If the variable is one of the legs, then we can replace the A or the B in that Pythagorean theorem. So now we can evaluate these. Let's look at your calculator. Everybody find your x squared button. It's 2 buttons to the left of the division symbol. So go ahead and tell me what 9 squared is. Tell me what 12 squared is. Make sure you know how to use the buttons. What's 9 squared, Kyle? Okay. What's 12 squared? Yuri? 144. So we could take a shortcut. We could do 9x squared plus 12x squared on your calculator, and it would go ahead and add that together for you. So now we know that x squared equals 225. We want to know what the side length, what that number is. It represents the length of that hypotenuse. So we have to get the x by itself. Is it x by itself right now? Wait, say it again? Yeah, so it has to be x to the first power, not x squared. So what can we do to x squared to get it to be equal to x? What operation? Very good. The square root memorize that. So the square root of any squared thing, so for instance, the square root of 9 is the number that we can multiply by itself to get 9. So 3 times 3 is 9. The square root of 9 is 3. The square root of any variable squared is just that variable. So if we take the square root of x squared, then we get x. Now, it is perfectly okay to take the square root of x squared in that equation. But remember, when you're working with equations, you have to do the exact same thing to everything on the left side and everything on the right side. So if I take the square root of the left side, that allows me to take and mandate that I do the same thing to the right side. So in order to get x by itself, I took its square root. So in order to get to the value of x by itself, I take the square root of 225. So now we're going to clear out our calculator, enter 225, and press the square root button, which is the button directly to the left of your division button. So when you take the square root of 225, what'd you get, Sharad? Say it again? Yes. So now we know the length of this hypotenuse is 15. We're going to do the same thing here. Before we can plug into the Pythagorean theorem, we've got to figure out which sides are our legs and which sides are the hypotenuse. So what do you think, Tarlin? Is the x a leg or a hypotenuse? Very good. Is the 10 a leg or a hypotenuse? Good. So those are going to be A and B or B and A. That doesn't matter. So that's going to make this one the hypotenuse, right? So now we designated this as A. So we're going to replace A with 10. We designated this leg as B. So we're going to replace the B with X. And then finally, we determined that this was a hypotenuse. It's the side across from the right angle. It's not one of the sides that is creating the right angle. So we're going to replace that there. So now we're going to simplify those powers or evaluate those powers. What's 10 squared? What's 10 squared? 100. Yeah, I can't really hear. I got a fan going over here. So 100. X squared we don't know, so we're going to just bring that down. What's 19 squared? 361, Corey says. There we go. Okay. So now we've simplified everything we can simplify. Now we've got to get x by itself again. What's the process for getting x by itself in this situation? Corey? Very good. We're going to subtract 100 from both sides, right? If I subtract 100 from both sides, that leaves me x squared. If I subtract 100 from 361, that leaves me 261. What do I have to do to get x squared by itself? Square root it, right? And when I take the square root of x squared, I just have x, because x times x is x squared. Now, if I take the square root of x squared, I got to take the square root of 261. What do you get when you take the square root, find the square root of 261? Kyle?
16.155.
155. Now, here's the question. I teach a senior level class right now, and one of the things they struggle with, they can't round. Oh, some of them can round. But I wanted to make sure I remind you, sometimes they're going to ask you to round to the nearest hundred. Sometimes they're going to ask you to round to the nearest whole number. Sometimes they're going to ask you to round to the nearest tenth place. So I wonder we're going to give you a little refresher. I've got number 1.234 here on the board. 1 is the whole number, right? So the decimal place to the left of the decimal point is the whole number. The decimal place to the first place to the right is the tenth. The second place is the 100. The third place is the 1,000. We're probably not going to ask you to round to the 1,000. It's usually the tenth or the hundredth, and occasionally the whole number. How do you round? Does anybody remember how to round? Right? What's going to be above 5? So let's say, because it asks us to round the nearest hundredth here, this is that number, right? So which number is in the hundredth place right now? Well, the first 5, right? So how do I use the rule you said is going to be greater than 5? What does that mean? The number to the right of that is a 5. If it's 5 or greater, then that 5 that we're rounding to will go up to a 6. If it's less than 5, it stays where it is. So ours is going to round to 16.16. Okay? Rounding doesn't seem like a big deal, but Shrag, you okay? But when you're rounding, if you round wrong in a digital computer test, you don't get any partial credit, right? So make sure you know how to round and which place you're supposed to be rounding to. All right, so let's look at this. Well, these triangles. How many triangles do you see?
3.
Very, that's what I see, 2, 3. Do you see 3 triangles, Dominic? Do you see 3 triangles, Jasmine? Yeah. So there's a big one, RQT. And then there's 2 smaller ones, right? So this segment QS splits this big triangle into 2. So there's an RQS and there's an SQT. This problem asks us to find the length of RT, right? So I'm happy to see that this big triangle is a right triangle, because I think, well, maybe I can use the Pythagorean theorem. If I know 2 of the 3 sides, I can do that. There's a little problema, though. On this big triangle, I want to know this whole length. And I only know one side length, and that's the hypotenuse, right? I don't know the length of this leg, and I don't know the length of this leg. So I'm thinking, well, if I knew how long segment RS was, I could add it to 21 and I'd have the length of RT. Does that make sense to everyone? Does that make sense to you, Leo? Okay. But is there any way for me to find the length of RS? Well, RS is one of the sides of this triangle RQS, right? Do I have any information here that will let me find the length of that segment? Well, 21's not part of that top triangle, right? Yeah. So I can't use this triangle, but RQT and SQT share a leg, right? They're both right triangles. SQT and RQT, they have, one of their legs is the same. QT is a leg in both triangles. Does that make sense? So we also have, in this little triangle, if we know that we have one leg and one hypotenuse. So we could find the length of QT by using the Pythagorean theorem on this smaller right triangle. Now, if we know what this length is, and we have this length, then we could use the Pythagorean theorem to find the whole length of RT. Does that make sense? Does that make sense to you, Kendall? So what you have to do is you got to make yourself a little plan. The answer's not always going to be right in front of you, right? So you got to figure out how you can split this up into parts and triangles that you can use something we've learned this year to solve it with, right? So what we're going to do is we're going to find the length of QT, and we're going to call that X. So the length of QT is X. So we don't know what that is, but we know one of the legs is 21, and we know that hypotenuse is 35. So we're going to plug in to the Pythagorean theorem again, right? So we're going to call, I forget which one I called, so we're going to call this one A, and this leg QT, we're going to replace that X with for the B, and the hypotenuse of this triangle is 35. So we've used this Pythagorean theorem, and now we can evaluate 21 squared. What's 21 squared, Yuri? What's 21 squared? 441. What's 35 squared, Chris? No, not the square root. Yeah, so that's one of the things you have to distinguish between square root and square are not the same thing, right? If you square something, you're usually making it bigger. Say it again? Now, to get X by itself, we've got to subtract again, like Corey said on the last problem. We're going to subtract 441 from both sides. If I subtract it from this side, I get X squared. If I subtract it from this side, I get 784. So we're finding the square root of X squared, which we know is going to give us X. And now we can take the square root of 784. What's the square root of 784, Lee? 28 is it. So now we know the length of QT, the length of this leg in both triangles is 28. So now, if we're looking at this triangle up here, the hypotenuse, so we've got a leg, and a hypotenuse, and we have the length of two of the sides. So now we can plug in, and we're going to just say that this one is Y to make it easier on ourselves. So we're going to say the length of RT, that's what we're solving for here, is Y. We need to know how long the whole thing is, and we're going to plug into the Pythagorean theorem. So 28 is one of the legs, 28 squared. The other leg that we don't know, we're calling Y squared. The hypotenuse of this big triangle is 53. We could take a shortcut here. We know we're going to be subtracting whatever 28 squared is. You could take 53x squared minus 28x squared and skip all the way down to this step if you like. You can also evaluate them and then subtract them. So in terms of what work are you required to show me, it would be this step and this step. Does that make sense, Andre? All right, so now, anytime I see a square on that variable, I got to take the square root, square root of both sides of that equation. The square root of 2025 is 45. So now I know the length of RT is 45. So far, so good? Okay. Caught up with me? Sergio, you good? Okay. And Jay, are you good? All right, quick review. How do you know if three side lengths will make a triangle? Right, when you add the two shortest, it has to be greater than the length of the longest, right? So if you had three side lengths for this example here, there were 6, 7, and 10. This one will make a triangle. Remember, triangle is a polygon, which means it's a straight-sided closed figure. So that means the sides have to be able to reach to close it into a triangle. If the sum of the two shortest sides is greater than the longest side, then it can form a triangle. But here, this doesn't make any sense, right? 6 plus 7, that's not greater than 20. 13 is less than 20. In order for this to make a triangle, it would have to be greater than 20. So, if the sum of the two shortest is not greater than, remember, it can't be equal to either. It's got to be greater than. Cannot form a triangle. All right. So now here's what we're going to use the converse of the Pythagorean theorem. Basically, that just kind of means we're working backwards. We're still using the Pythagorean theorem, but instead of them telling us it's a right triangle and we're looking for a side length, now they're going to give us three side lengths and say, is this a right triangle? If these were the side lengths of a triangle, would they be a right triangle? So, the straight Pythagorean theorem says if this is true, then the triangle would be a right triangle. Now, if you add the squares of the shortest sides together, and they're less than the longest side squared, well, that can't be a right triangle. All right? What that would be is an obtuse triangle. Does anybody remember what an obtuse triangle is? What's greater than 90? All of them? You could have one angle that's greater than 90 but less than 180, right? Right. Okay, so here's the deal. An obtuse angle, so a 95-degree angle, that's an obtuse angle. So if it's an obtuse triangle, at least one, that would be an, if one of those angles is 95 degrees, it would be an obtuse triangle. So if the sum of the side lengths, short side lengths squared is less, then it's an obtuse. Let's make some notes on here. You should be circling and underlining like I am. Now what if we square the two shortest sides and they're greater than the longest side squared? Well, then we will have an acute triangle, which means that all three angles are less than 90 degrees. Basically, if it's not a right triangle and it's not an obtuse triangle, it's going to be an acute triangle. Questions so far? We good?
I have a question.
Kyle?
So just one of the angles are over 90 degrees.
Correct. All right, so this is kind of what it's going to look like on your assignment. At least one part of your assignment today. Going to give you this table. Its directions say determine whether a triangle with the given side length is a right triangle. So A, 3 side lengths, 14, 48, and 50, right? We're going to plug into the Pythagorean theorem formula and see, is the left side equal to the right side? If it is, we'll know it's a right triangle. So remember, they didn't say right triangle, but if it's a right triangle, the legs are going to be the short sides, right? So we're going to have to assume 14 and 48, those are going to be our legs, and we're going to plug in to the Pythagorean theorem formula shy of the equal sign. We're not going to enter that. So 14 squared and 48 squared. How do they compare to that longest side squared? So if we add that together, how does it compare to the longest side squared? Cam, you write what I'm writing? Put your backpack down, buddy. You're a little too comfortable. Think you're going to sleep on me. All right, so on your calculator, let's see what shortcut. 14x squared plus 48x squared. What does that equal? Leo? I mean, we can doodle, we just can't be all doodle. We can do it one step at a time, but we can also use our calculator. What do you get? Can't see it. 2304. Is the sum of those? Nope. So try again. 14x squared plus 48x squared equals on your calculator. What do you get? Say it again. 2,500. Yeah. You're only doing the 48 squared. You're going to do the 14x squared plus 48x squared equals. Try it again. Plus. Did you get it? Did you get it? Yeah, I did say his equal sign, right? All right, so the left side is 2,500, the right side is 2,500. They're equal, so now we know it's a right triangle. So that's how we use the converse of the right triangle. We think of the Pythagorean theorem. We're usually using the Pythagorean theorem to find the side lengths, but here we're using it kind of backwards to prove that a triangle is or is not a right triangle. Well, let's look at B. 6, 8, and 10. The legs have to be the shortest side, so 6 and 8 are going to be part of the sum. 10 is the longest side. So 6 squared plus 8 squared. How does it compare to 10 squared? Dominic? What's 6 squared plus 8 squared? Use a shortcut on your calculator. 6x squared plus 8x squared equals. What do you get? Yeah. You could do it one step at a time, but we could also use our calculator to its fullest benefit and skip that step. So 100, 10 squared is 100. The left side is equal to the right side, so once again, we know that that triangle, if it had these side lengths, would be a right triangle. All right. So what am I going to plug in for C to determine if this triangle would be a right triangle? What do you think? Nisha? What would I plug in? Say it again. Yep, that's exactly right. 8 squared plus 10 squared. Now what? Yep. What gets plugged in up here? 13 squared, right? Yep. And that is 169. Are they equal? Are they less than or greater than? Does less than or greater than go here? 164 less than or greater than 169? Less than. Right. So now we know this is not a right triangle. They didn't ask us this, but can you tell me, if it's not a right triangle, is it an acute or is it an obtuse triangle? Look at your notes. Would that be an acute or an obtuse triangle? It would be an obtuse. Very good. If the sum of the short sides is greater than the sum of the square of the short sides is less than the square of the longest, it's obtuse. All right, let's plug in for D. What am I going to plug in here, Charlene? What am I going to plug in to determine if this would be a right triangle or not? Good. So what am I going to put? 8 what? Beautiful. And what's the last one going to be? 16 squared. And you can use the shortcut strategy on your calculator. What's 8 squared plus 14 squared? AJ? What's 8 squared plus 14 squared? So use the shortcut. 8x squared button plus 14x squared button equals. Very good. And 16 squared, I just showed you, is 256. So they're not equal. It can't be a right triangle. Once again, they did not ask us this. 260 is greater than 256. So now we know it's what kind of triangle? Acute. It's kind of the opposite of what I would think. This is less than, and it gives me an angle that's greater than 90. This is greater than, and all the angles have to be less than 90. So it's a little bit of the opposite, counterintuitive, as we might say. Y'all caught up with me? Okay. The side lengths of two triangles. So this is a little bit simpler problem, determining if it's a right triangle, acute triangle, or an obtuse triangle. They do a little bit of the work for you. It says one triangle has side lengths 18, 5, and 16. Compute the sum of the squares of the shorter length. Compute the squares of the longest length. And then we should be able to tell them based on that what kind of triangle it is. So let's use the shortcut. Now, they did this part for us, but if they didn't write this equation for you, you have to know to use 5 and 6 in that first part, right? 5 squared plus, 5 and 16, because that's the two shortest sides. So 5 squared plus 16 squared, do it on your calculator. 5 squared plus 16 squared. What is it? Say it again? 281. Very good. What's 18 squared? 324. So now, the sum is on the left, and that longest side squared is on the right. 281 is less than 324. It's not equal to, so it can't be a right triangle, right? So is it a acute or an obtuse? Very good. All right, here, same thing. You have to know to use the two shortest sides if they don't give you this part. So, given side length 10, 12, and 9, what kind of triangle would they form if you created a triangle with those side lengths? Well, let's do 9 squared plus 10 squared. What do you got, Yuri? 9 squared plus 10 squared. What do you got? Use 9x squared button plus 10x squared button and equals 181. What's 12 squared? 144. So remember this, the sum goes in the left, the other one goes in the right. 181 is greater than 144. So what kind of triangle is it? Acute, right, or obtuse? Acute. The greater than is going to be acute. All right, any questions? One more, right? Y'all caught up? Yeah. All right. Find the distance between points A and B given below. Round your answer to the nearest 100. Or the nearest 100. We could use a distance formula for this. We learned how to do this already. We've used it multiple times. Well, not right as ever run. No. Length, right? You're finding the slope, Jamari. I like that. You're throwing impressive vocabulary terms out of me, but we could find the slope of that line using right as ever run. But how can we tell how long that segment is if we don't use the distance formula? Anybody have an idea? Well, think Pythagorean theorem. Think right triangle. There's not a triangle there, though, right? Anybody have an idea? So if it goes straight down from B, that's only two sides. Then you connect it. So what Jamari is saying, I believe, is that we're going to draw a right triangle with segment AB as a hypotenuse. So he said, go down from B and then connect it from A, right? And now, if you connect them, these two sides are perpendicular, which means that's a right angle, which means it's a right angle, and we can use the Pythagorean theorem if we know this side length and this side length. So do we know how long this leg is? Okay. Yeah, we just can count because it's vertical, right? The vertical line. Vertical line or a horizontal line on the coordinate plane, we can just count the number of units. So this is going to be 4. And if we count here, 1, 2, 3, 4, this one's also going to be 4. So these are the legs. Remember, that's the hypotenuse is C. So we can use that same formula again, right? So the legs, 4 squared plus 4 squared equals 16 squared. Sorry, equals C squared, not 16 squared. You could use the shortcut and go straight to here, but I evaluated it there. So do we know what C is yet? No. What are we going to do to find C, Sharad? Yep, take the square root of C. When we do, we get C, which is what we want. But we also have to take the square root of the other side of that equation, right? And it asks us to round to the nearest 100. So the square root of 32 is 5.656, and a bunch of other numbers. Right? Hundredths place. The second to the right. 1, 2. So we look to the right. So we're either going to keep 5.65 or 5.66. It's going to go up to 5.66. Which is it going to be? It's going to go up to 66 because the number to the right of the place value we're rounding to is greater than 5. So that's how we know it's going to be 5.66 units long. Approximately, because we've rounded. Some of the lessons we're going to work with, we're going to give exact answers, which means in this situation we would simplify that radical. But for right now, we get to take the easy way out and round. Any questions? All right, go ahead and scan and submit your notes. Do I need to go back?
For those obtuse in the queue, I wrote like little definitions. Well, it's like for right, they all have to be right or only
One right angle.
Just only one.
One right angle.